Good evening everyone. I am Shivani Dhok and I welcome you all for the week 4 tutorial for the course of Digital Signal Processing and its applications. So like every week, this week's tutorial will be divided in two parts. First, I'll have a quick recap of week 4 content and followed by the questions related to the content of this particular week. Okay, so let me start with the recap of week 4 content. You may stop me at any point to ask your queries. Feel free to unmute yourself and raise your hand. So this week 4 was totally based on discrete-time Fourier transform and its property. So just to recap quickly, this discrete-time Fourier transform for let's say a signal x of n is x of omega, and this x of omega is simply summation n running from minus infinity to infinity x of n into e power minus j omega n. And if I want to reconstruct back this x of n from x of omega, then I have inverse DTFT that I can do by doing something like this. It is 1 over 2 pi integral over a range of minus pi to pi x of omega into e power j omega n d omega. After that, a few properties of DTFT were discussed. So the first thing that was discussed was linearity property. So if I have x1 of n with the corresponding DTFT as x1 of omega, and if I have x2 of n with corresponding DTFT as x2 of omega, then its linear combination, that is alpha x1 plus beta x2, will have the Fourier transform DTFT as alpha x1 of omega plus beta x2 of omega. After that, the time reversal property was discussed. So it says that if x of n has of DTFT x of omega, then x of minus n will have a DTFT as x of minus omega. After that, conjugate property was discussed. That is, if I take complex conjugate of the signal x of n, then its DTFT will be x of minus omega conjugate. After that, the convolution property was discussed. So if I take the convolution of x1 of n with x2 of n, then its corresponding DTFT will be x1 of omega into x2 of omega. After that, we have time multiplication, then x1n into x2n. Then its DTFT is given by this periodic convolution as mentioned here. After that, Parseval's theorem was discussed. So it says that summation n running from minus infinity to infinity x1n into x2n conjugate is equal to 1 over 2 pi integral minus pi to pi x1 lambda into x2 lambda conjugate d lambda. After that, the energy spectral density was discussed, where this energy spectral density is this quantity and the time spectral density is this quantity. Any questions till this point?
No, ma'am.
Okay. Okay, so let's start with the question 1 that I have planned to cover today. So the first question says, this is a very simple question. So it asks that what is the sufficient condition for a discrete time signal to have a well-defined Fourier transform? So the first option is only finite valued at all time instants. Second option is summable over all time instants. And third option is absolutely summable over all the time instants. So which is the correct option? Which is the correct option in this case for this particular question? Yes, sir?
Is it 3, madam?
Yes, correct. So for a Fourier transform, so let's say if I have x of n, and we have this x of omega. This will exist if summation n running from minus infinity to infinity, magnitude of xn is less than infinity, which corresponds to option 3. So one thing we need to note that this is absolute summation and not simply summation. So this absolute thing is important. This comes from that boundedness and other things. Okay. If there are no questions, then I'll move on to the third question. So on, yes, sir.
Please make the screen bigger, madam.
This is okay?
Fine, madam.
Yeah, thanks. Okay. So the second question says that find the convolution. So we need to find the convolution of two signals. First one is x1 of n is 2 to the power minus n un, and second signal is x2 of n equal to 3 to the power minus n un. So I'm purposely putting this convolution question here because we'll use this result in upcoming questions. Okay. So what do we have? We have, just make this as normal screen. So we have x1 of n is equal to 2 to the power minus n un, and x2 of n is equal to 3 to the power minus n un. So let's say y of n be the convolution of these two signals, which is equal to, by definition, summation k running from minus infinity to infinity x1 of k into x2 of n minus k. So this is equal to summation k running from minus infinity to infinity. So this 2 to the power minus 1 is simply 1 by 2. So I can write this as 1 by 2 to the power k into u of k into 1 by 3 to the power n minus k into u of n minus k. So this 1 by 3 to the power n is constant, so I can take it outside. So I can write this as 1 by 3 to the power n into summation k running from minus infinity to infinity 1 by 2. You can also take this 1 by 3 to the power minus k inside this, so into 3 to the power n, sorry, to the power k into u of k into u of n minus k. Okay, so now this I can write as 1 by 3 to the power n into summation k running from minus infinity to infinity 3 by 2 to the power k into uk into u of n minus k. So this product here, this thing, we had seen in previous lecture that this is 0 if n is less than 0. Also, this is 1 belonging to 0 to n and 0 otherwise. And this is true if n is greater than or equal to 0. So how did this come up? So this, just for a quick revision, I'll redo this thing. So this u of k looks something like this. And this is 0 here. So this is u of k. And this u of minus k is simply flipped version of this signal, which will be something like this. And how does u of n minus k look? So u of n minus k is equal to u of minus of k minus n. So basically I'll have to shift this signal this side by n units. So it will be shifted rightwards if my n is positive, it will be shifted leftwards if my n is negative. So if my n is less than 0, then it will be shifted something like this, and the uk into u of n minus k will be 0. However, if I shift it rightwards something like this, then there will be some overlap and therefore it won't be 0. So for n greater than or equal to 0, u of n minus k looks something like this. This is 0, this is n, then after that it will be 0. Okay, so now multiplication of these two signals will be non-zero only for a range of 0 to n, otherwise it will be 0. I hope this is clear. So the summation that we are having here, so what are we having? We have this y of n is equal to 1 by 3 to the power n summation k running from minus infinity to infinity 3 by 2 to the power k into u of k into u of n minus k. This thing I can write as 1 by 3 to the power n summation k running from 0 to infinity 3 by 2 to the power k. And when is this true? Sorry, not infinity, to n. And when is this true? This is true when my n is positive. So this indicates for n greater than or equal to 0, it's not equal to 0. Okay. So now this thing here is simply a geometric progression with common ratio 3 by 2 and first term as 1. So this we can write as 1 by 3 to the power n multiplied by first term is 1, so it's okay. Then we'll have 3 by 2 to the power the number of terms. So 0 to n will be n plus 1 minus 1 upon 3 by 2 minus 1. So this thing here is 1 by 3 to the power n. Inside the bracket, this thing will be, can write this as 3 by 2 into 3 by 2 to the power n minus 1 upon 1 by 2. So if I simplify this thing here is 3 into 1 by 2. So yeah, there is a u of n here into 1 by 2 to the power n into un minus 2 into 1 by 3 to the power n u of n. Any questions till this point? Is it okay? This is the final answer that we wanted. Any questions till this point? Okay. So if there are no questions, let me move on to the next question that I have planned to cover today. So it says that verify the convolution property of DTFT for the previous question. Okay. So what did we have in the previous? Yes, sir. Yes, sir. Please ask your question.
No, madam, no. But repeat it. Sorry.
Okay, okay, okay. It's fine. Yeah. So what it says is we need to verify the convolution property of the DTFT for the previous question. So what was the previous question? In previous question we were asked to find out the convolution of two signals. Okay, so what we have is we have x1 of n as 1 by 2 to the power n u of n, x2 of n is equal to 1 by 3 to the power n u of n, and we had found out y of n equal to x1 of n convolved with x2 of n, which came out as 3 into 1 by 2 to the power n u of n minus 2 into 1 by 3 to the power n u of n. Okay, so what we need to verify? So to verify is y of omega equal to x1 of omega into x2 of omega, where x1 of n has a DTFT as x1 of omega, x2 of n has a DTFT x2 of omega, and x3 of n sorry, y of n has a DTFT y of omega. Okay, so this is the thing that we need to verify, right? So now if you observe carefully, this thing here, this thing here, and this thing here are of the form of a to the power n un, where magnitude of a is less than 1. Okay, so for simplicity what we will do is we will consider some signal xn as a to the power n into un, and mod of a is less than 1. Okay, and for that let us find out this x of omega, which is equal to summation n running from minus infinity to infinity a to the power u of n in a to the power n u n into e power minus j omega n. So this thing here, since we are having this unit step function here, so I can change the limits from n equal to 0 to infinity a to the power n into e power minus j omega n. So this I can write as summation n running from 0 to infinity a into e power minus j omega whole to the power n. Now this is an infinite geometric progression, so this thing here is infinite geometric progression with common ratio as a into e power minus j omega, and this magnitude is a, which is less than 1, and therefore it will converge. Okay, so therefore x of omega will be equal to first term is 0, 1 upon 1 minus common ratio 1 minus a into e power minus j omega. So what result do we have? So we have, if x of n is equal to a to the power n un, where magnitude of a is less than 1, then x of omega is equal to 1 upon 1 minus a into e power minus j omega. So this is the result that we are having here, and let me number it as 1. So now let us go back and look at our x1 of n and x2 of n, which are of that particular form. So let us consider x1 of n. So what do we have? x1 of n is equal to 1 by 2 to the power n into un. So here, if I compare it with this form here, so my a is equal to half, which is less than 1. So therefore, my x1 of omega will be equal to 1 upon 1 minus a, that is half, into e power minus j omega. Okay. Similarly, what was my x2 of n? So this x2 of n was 1 by 3 to the power n into u of n. Here a is 1 by 3, which is again less than 1. So therefore, x2 of omega is equal to 1 upon 1 minus a is 1 by 3 into e power minus j omega. Is it clear till this point?
Yes, ma'am.
Okay. Okay. Yeah. So now let us consider yn. So this y of n we had obtained as 3 into 1 by 2 to the power n u of n minus 2 into 1 by 3 to the power n u of n. Now if you observe carefully, this thing here is simply x1 of n, and this thing here is simply x2 of n, right? So I can write this as 3 into x1 of n minus 2 into x2 of n. So therefore this y of omega will be 3 into x1 of omega minus 2 into x2 of omega. And why is this so? This is by linearity property. Okay, so let us substitute this x1 of omega and x2 of omega here. So this x1 of omega is 1 upon 1 minus 1 by 2. So this is 3 upon 1 minus 1 by 2 into e power minus j omega minus 2 upon 1 minus 1 by 3 into e power minus j omega. So let us simplify this. So this is 3 minus e power minus j omega minus 2 plus e power minus j omega upon 1 minus 1 by 2 into e power minus j omega multiplied by 1 minus 1 by 3 into e power minus j omega. So now this thing gets cancelled. So what is left is this y of omega is equal to 1 upon 1 minus 1 by 2 into e power minus j omega multiplied by 1 minus 1 by 3 into e power minus j omega. So now I can write this as 1 upon 1 minus 1 by 2 into e power minus j omega multiplied by 1 upon 1 minus 1 by 3 into e power minus j omega. So if you observe carefully, x1 of omega is this quantity, which is equal to what we have obtained here. So this quantity here is simply x1 of omega. Similarly, this quantity here is x2 of omega. See, this is x2 of omega. So therefore, this y of omega is equal to x1 of omega into x2 of omega. So we verified the convolution property. Any questions? Anyone has any questions? Okay, if there are no questions, then let me go ahead with the fourth question. So here is the fourth question. So it says that if the Fourier transform of the discrete time signal xn equal to 1 by 2 to the power n into u of n plus 3 is of the form this, where un is the unit step function, then what is the value of a? So for this particular signal, we have been given the form of its Fourier transform, and we need to find this value a. So let's start with it. So what we are given is this x of n is 2 by 3 to the power n into u of n plus 3. So this x of omega is equal to summation n running from minus infinity to infinity x of n, which is 2 by 3 to the power n into u of n plus 3 into e power minus j omega n. Okay, now this thing here, u of n plus 3, this becomes non-zero for its argument greater than or equal to 0. So this thing here should be greater than or equal to 0. So this is 0 for n plus 3 less than 0 or n less than minus 3, and it is equal to 1 for n plus 3 greater than or equal to 0 or n greater than or equal to minus 3. So if I just simply remove this unit step function and change the limits from n ranging from minus 3 to infinity, it's okay. So therefore this x of omega is equal to summation n running from minus 3 to infinity 2 by 3 to the power n into e power minus j omega n. This I can write as summation n running from minus 3 to infinity into 2 by 3 into e power minus j omega whole to the power n. Again, this is an infinite geometric progression, but now the first term is 2 by 3 into e power minus j omega to the power minus 3, and common ratio is 2 by 3 into e power minus j omega. So therefore this thing is equal to first term, which is 2 by 3 into e power minus j omega to the power minus 3 upon 1 minus 2 by 3 into e power minus j omega. So therefore this I can write as 3 by 2 to the power 3 into e power j omega 3 whole divided by 1 minus 2 by 3 into e power minus j omega. So if we compare it with this form which is given here, what we have obtained the value of a as 3 by 2 to the power cube to the power 3. So therefore this a is equal to 3 by 2 to the power 3. Okay, any questions till this point? Okay, so if there are no questions, let us solve this same question in another way. So for that, what we'll do is we'll look at one property of DTFT which is known as time shift property. Okay, so what does it say? If x of n has a DTFT as x of omega, and if I shift this x of n by a factor of n naught, what will be the DTFT of this quantity here? Okay, so let us try to find out. So let's say that this thing here is x tilde of omega. So this x tilde of omega is equal to summation n running from minus infinity to infinity x of n minus n naught into e power minus j omega n. Now what we will do, we will substitute n minus n naught as m. Therefore this n will be equal to m plus n naught, and if n is running from minus infinity to infinity, this m will also run from minus infinity to infinity. So now we have summation m running from minus infinity to infinity. We have this as x of m into e power minus j omega, and n I can replace as m plus n naught. So now this term here I can write as e power minus this term here I can write as e power minus j omega m multiplied by e power minus j omega n naught, and this n naught is constant term, doesn't depend on m, so I can take it outside. So now I have this as e power minus j omega n naught into summation m running from minus infinity to infinity x of m into e power minus j omega m. Now if you look carefully, this thing here is simply x of omega, which is the DTFT of this quantity, right? So therefore this thing here x tilde is e power minus j omega n naught into x of omega. So therefore what did we prove? If I shift my original signal by a factor of n naught, then this will have a DTFT as e power minus j omega n naught into x of omega. Okay. Okay, yeah. So this we know. This we have just proved. Any questions in this proof? Now we'll try to use this property in order to solve the same question that we have solved a bit before. Okay. Okay, so in our question, what did we have? So we are given x of n is equal to 2 by 3 to the power n into u of n plus 3. So now what I'll do, I'll write this as 2 by 3 to the power n plus 3 minus 3 into u of n plus 3. Okay, so this is equal to 2 by 3 to the power minus 3 into u of into 2 by 3 to the power n plus 3 into u of n plus 3. Okay, Now let x tilde n be defined as 2 by 3 to the power n into u of n. Okay, so if that is the case, then this quantity here is simply x tilde of n plus 3. Okay, now this thing is of the form a power n u of n with a magnitude of a less than 1, and we had seen that this has a Fourier transform as 1 minus a to the power a into e power minus j omega. Okay, so this x tilde omega is simply equal to 1 upon 1 minus 2 by 3 into e power minus j omega. Okay, now let's get back to our original x of n. So what did we have? We have our x of n as this 2 by 3 to the power minus 3, I can write as 3 by 2 to the power 3 into x tilde of n plus 3. Now let's get back to the property which we derived. So we saw that this x of n minus n naught will have a DTFT as e power minus j omega n naught x of omega. So now let us apply this property to this thing here. So in this particular place, if I compare it with n minus n naught, then here n naught is equal to minus 3. So therefore DTFT of this quantity will be e power minus j omega n naught, which is minus 3 into x tilde of omega. Okay, and x tilde of omega we have obtained as this quantity. So therefore, if I take DTFT of this, then x of omega will be equal to 3 by 2 to the power 3 into e power minus j omega into n naught, which is minus 3 into x tilde of omega. So this thing will be equal to 3 by 2 to the power 3 into e power j omega 3 divided by 1 minus 2 by 3 into e power minus j omega. Now again, if we compare with the form which we are given, then this a comes out to be 3 by 2 to the power 3, which was exactly the value which we found out using the standard approach. Any questions till this point? So if you observe carefully, this exponential signal, this 1 by 2 to the power n, or rather a power n un, is a standard signal, and generally the DTFTs of these signals or any properties of these signals are well known. So if the properties of these signals are well known, and if we are given some modifications of this particular signal, this particular form or any given standard form, if we are given this thing, then it is easy to apply a property. So here, instead of finding that entire summation which we did here, this entire math which we did here, it was easy, much more easier to apply this simple time shift property than doing that summation. Both of the approaches are very correct. Nothing is wrong in both of them. But in certain situations, it is much easier to apply the properties than getting involved in finding summations and integrals and those things. So if you know the relations between, if you know the properties of DTFT, it is easy to solve several questions faster and with less possible mistakes. Any questions? Any questions till this point? Okay, if there are no questions, then let me move on to the next question that I had planned to cover today. So it says that suppose the discrete time signal xn is equal to 12053, and this 5 is basically x of 0. Let x of omega denote the DTFT of xn. Then we need to find the value of this quantity. Okay, so one simple approach will be, so what it says is, let's write down that approach. So approach 1 is find x of omega and then find integral minus pi to pi x of omega d omega. So this approach might be complicated. It's too much involved. So can we do something simpler? So let us try to do that. So for that, what we will do is, let us write down the reconstruction equation. That is, write down how do we get x of n from x of omega. So we have this as 1 over 2 pi integral minus pi to pi x of omega into e power minus j omega n d omega. Okay, so now I can write this as integral minus pi to pi x of omega into e power minus j omega n d omega is equal to 2 pi into x of n. Okay, so what, do we need to find this integral? No. So the integral that we need to find out is this quantity, this one here, this one. However, what we are getting is this. So we are getting this additional term here. So how can we eliminate this term? So we can eliminate this term if we substitute n as 0. So basically, if I look at x of n at n equal to 0, then, so what we will do, consider n equal to 0. So if that is the case, then this thing here will become 1 and this thing here will become x of 0. So what we will have integral minus pi to pi x of omega d omega, which is equal to 2 pi into x of 0. And what is the value of x of 0? So this x of 0 is equal to 5. Okay, so this x of 0 is 5. Therefore, this integral is equal to 2 pi into 10, which 2 pi into 5, which comes out to be 10 pi. Any questions?
Ma'am, you have written about x of n is equal to 1 by 2 pi over minus pi to plus pi. X of omega
Sorry,
into,
it's a plus. It should be
it should
plus.
be plus.
Plus,
Oh,
plus,
yes, yes.
plus. Yeah,
Okay.
sorry. It should be plus. Any other questions? Okay. If there are no further questions, then let me move on to the next question. Yeah. So what is given is, suppose the frequency response of a digital filter is given. So this is the frequency response. Yes, sir.
Madam, you did for n is equal to 0. Others are similarly has to be carried out.
Sir, this integral here is a function of omega.
You have so several values in xn now.
See, this xn is equal to 1 over 2 pi integral minus pi to pi x of omega into e power j omega n. So this relation we know, and what we wanted to find out was this equation.
Only at n is equal to 0 you asked.
I didn't ask at n equal to 0, I asked the value of this quantity. But the relation that we know is this quantity here. So
No,
can we somehow use this equation and reduce it
Yeah.
to what we wanted to find out? So
You
by
did it, madam.
observation we understand that this can be done by putting n equal to 0.
No, there are other values also known, man.
How will you solve it, sir?
No, I don't know. That you have to say.
Yeah, you solve it for n equal to 2 or other things also. But then,
Like that
then you will have this integral to be solved.
Yeah, integral we can solve now.
Okay, so you try it out once and you may put the solution in the ask me a question thing.
I think you will get five sequences like that, no? Because
No. This
you
is
won't
okay.
get 5 sequences.
Not
You won't
needed.
get 5.
This is one sequence. This x of n itself is one sequence. And when I'm changing the value of n, I am changing the index of that sequence which I'm referring to.
So only 0 value are taken. Okay.
The question says that I want to find this integral.
Yeah, you are doing that.
Okay. So one way is you find x of omega from this given thing and then you integrate. Okay. It will be much more complicated. So what I propose to do, I propose to look at this particular thing here and then somehow reduce this integral to required form.
So n is equal to 0 you kept, madam. Similarly, there are n is equal to 1 is there, minus 1 is there, minus 2 is there, minus 3 is there. What are the cases then?
Sir, in any case, whatever you put.
No, only one answer will be. How do you know that only we have to take n is equal to 0 only?
So that is by observation, na sir. 1 second. Let me add a page and then show. 1 minute. So what is given to us is we want integral minus pi to pi x of omega into e power minus j. Sorry. We want this, right? This was asked in question. What is this equal to? Now what relation do we have? The relation that we have is x of n equal to 1 upon 2 pi integral minus pi to pi x of omega into e power j omega n d omega. Okay. Now if I want to reduce this particular integral to this, what will we do?
Just blindly we will put n is equal to 0.
Sir, if you put n equal to 0, if you evaluate what, okay, by looking at this equation,
but
here.
No, I want to disappear e to the power of j omega n. I put n is equal to 0, I will getting. Then what is the necessary of x of n that equals? You have given 1, 2, 0, 5, 3. Not necessary now.
You need the value of x of 0, na? You need this value.
Where you kept the 5? 5 value. N is equal to 0, the value is 5. Where you kept that?
I put
at
here,
at the end. Okay.
Yeah, I used it. I have to use it somewhere.
So somewhere we have to think that we have to make it disappearment e to the power of minus j omega n. That's all. No?
Yeah. So okay, what I'm saying is this is an easier approach than using that entire
no,
sequence to find DTFT.
Approach is okay, madam. What about the rest of the values? 1, 2, 0, 3 are there? No.
It's okay, but we are not using them. See, this DTFT xn to x of omega is a unique mapping. Whatever you put, you will get same answer.
You don't want x omega sequence.
No. I don't want x of omega sequence. I just want this integral.
That all I want. Because x of n is you have given a sequence. 5 sequence you have given. 5 values you have given, no?
Yes, see.
So finally we should not get 5 values. We want only 1 value.
I want to find this integral. I don't care what this sequence is. Can I simply find this integral without finding this x of omega explicitly? In a simpler way.
Okay, you don't want x of omega also.
I just want that integral.
Understood. If you want x of omega only,
Then you use the standard definition. Now, what will be x of omega? 1 second. Let's find x of omega also. So 12053. This x of n is 12053. Right? Then this x of omega by standard definition will be summation n running from minus infinity to infinity x of n into e power minus j omega n. Right? Now if this is located at n equal to 0, this is at minus 1, this is at minus 2, and this is at minus 3, and this is at 1. So from minus 3 to 1 it is non-zero, otherwise it is 0. So this I can write as x of minus 3 into e power minus j omega into minus 3 plus x of minus 2 into e power minus j omega minus 2 plus x of minus 1 into e power minus j omega minus 1 plus x of 0 into e power minus j omega 0 plus x of 1 into e power minus j omega 1. So x of minus 3 is 1. So this becomes 1 into e power j omega 3. Then x of minus 2 is 2 plus 2 into e power j omega 2 plus x of minus 1 here is 0. So this term goes away. Then x of 0 is 5 into e power j minus j omega 0 is 1 plus x of 1 is 3. So 3 into e power j omega. So this is your x of omega. So x of
Okay,
omega
okay.
won't be a sequence.
Some of the sequence. Okay.
E
No, it's
power
not a
minus j
sequence.
omega.
Some
Sorry,
some
yeah. It's not a sequence, it is a function.
the function. Okay. Understood. Understood. Thank you.
Any other questions? Now you can use this x of omega and integrate it over minus pi to pi. You will again get the same answer which we have found out here. But you need to do this step, then do integration. It's too complicated. So this is a much simpler approach.
Got it, man.
Yeah. Any other questions? Okay. If there are no further questions, then let me move on. Yeah. So the question number 6 says that suppose the frequency response of a digital filter is given by this quantity here, and if the impulse response of the filter is hn, what are the values of h of minus 1, h of 0, and h of 1? Okay, so now the only way to solve this is to find the inverse DTFT of that quantity. Otherwise it becomes too complicated and we can't handle it. Okay, so what we are having is we have h of omega as 1 upon 2 minus cos of omega. Now handling this cos is a bit complicated, so what we'll do is we can write this as 1 upon 2 minus e power j omega plus e power minus j omega by 2. So this I can write as 2 upon 4 minus e power minus j omega minus e power j omega. Okay, so what do we have? We have as h of omega is equal to 2 upon 4 minus e power j omega minus e power minus j omega. So what I can do is I can take out this quantity e power j omega outside, e power j omega. So this becomes 4 into e power minus j omega minus 1 minus e power minus j 2 omega. Okay, so now this thing here is minus 2 into e power minus j omega divided by e power minus j2 omega minus 4 into e power minus j omega plus 1. So why are we doing these things? So if you observe carefully, or if you remember in second or third question, we had found out the DTFT of this quantity, and we had observed that this is of the form 1 minus a to the power e power minus j omega. So somehow can I bring this equation in this form, or linear combination of something similar, so that I can avoid using the inverse DTFT integrals, because integrating this into e power j omega thing is much complicated. Okay, so now what I'll do is, so now let us just focus on this thing. Just focus on this thing. Okay. So let me take this. So in this, let x is equal to e power minus j omega. So this thing I can write as x square minus 4x plus 1. And I want to factorize it. So if I want to factorize it, the roots of this equation will be x equal to minus b plus minus under root of minus 4 upon 2, which is equal to 4 plus minus root 12 by 2, which is equal to 2 plus minus root 3. So this thing I can write as x minus 2 plus root 3 multiplied by x minus 2 minus root 3, or I can also write this as 2 plus root 3 minus x into 2 minus root 3 minus x, which is equal to 2 plus root 3 minus e power minus j omega into 2 minus root 3 minus e power minus j omega. So now let us substitute this quantity back here. Okay. So what do we have? We have h of omega is equal to minus 2 into e power minus j omega divided by 2 minus root 3 minus e power minus j omega into 2 plus root 3 minus e power minus j omega. Okay. So we are having this quantity here. So now what we will do is, now let's consider this quantity. Consider two minus root 3 minus e power minus j omega minus 2 plus root 3 minus e power minus j omega. So this thing if I take, then this thing gets cancelled. This thing also gets cancelled, and what we are left with is minus 2 into root 3. So therefore we can write as minus 2 is equal to 1 by root 3 multiplied by 2 minus root 3 minus e power minus j omega minus 2 plus root 3 minus e power minus j omega. Okay. And again what I can do is I can multiply both sides by e power minus j omega. So I can multiply this as minus 2 into e power minus j omega, which is equal to e power minus j omega upon root 3 multiplied by 2 minus root 3 minus e power minus j omega minus 2 plus root 3 minus e power minus j omega. Okay, So now if you observe this thing here, so this quantity is exactly equal to this quantity, which we have found out as equal to this quantity. So what we'll do is we'll substitute this in place of this. So what we have now is, therefore, h of omega is equal to e power minus j omega upon root 3 multiplied by 2 minus root 3 into, sorry, minus e power minus j omega minus 2 plus root 3 minus e power minus j omega. Okay, divided by 2 plus root 3 minus e power minus j omega into 2 minus root 3 into minus e power minus j omega. So now this thing here is equal to 1 by root 3 inside the bracket. This is equal to e power j omega upon 2 plus root 3 minus e power minus j omega minus e power minus j omega divided by 2 minus root 3 minus e power minus j omega. Okay. So now let us consider, let's say this quantity here is A and this quantity here is B. So let us consider, or let me not do it, let me write this as x1 of A of omega into B of omega. So we have this A of omega as equal to e power minus j omega upon 2 plus root 3 minus e power minus j omega. Now what we will do is we will multiply and divide by 2 minus root 3, which is equal to 2 minus root 3 into e power minus j omega upon 2 minus root 3 into 2 plus root 3 minus 2 minus root 3 into e power minus j omega, which is equal to 2 minus root 3 into e power minus j omega upon, so this thing here will be equal to 4 minus 3, which is equal to 1. So this is 1 minus 2 by root 3 into e power minus j omega. Now this a of omega I can write as 2 minus root 3 into e power minus j omega multiplied by 1 upon 1 minus 2 minus root 3 into e power minus j omega. Now this thing here, or let me add a page, then I'll just copy this. Yeah. So this thing here is of the form of 1 upon 1 minus 8 into e power minus j omega, and here a is 2 minus root 3. So this root 3 is approximately equal to 1.732. So 2 minus 1.732 is obviously less than 1. So therefore this thing will have inverse DTFT as 2 minus root 3 to the power n into u of n. But now there is another thing that is coming up here, is this quantity. Okay, now what does this quantity indicate? Now recall time shift property, which we derived a few minutes some time back. So what did it say? If x of n has DTFT as x of omega, then x of n minus n naught has DTFT as e power minus j omega n naught x of omega. So now here this quantity is x of omega, and this quantity corresponds to this particular thing here. So if I compare this quantity and this quantity, this thing here is simply, this indicates that here n naught is equal to 1. So therefore e power minus j omega into 1 upon 1 minus 2 minus root 3 into e power minus j omega. So if this thing is x, or yeah, x tilde n, then this thing will have DTFT as x tilde of n minus 1. So therefore this will be equal to 2 minus root 3 to the power n minus 1 into u of n minus 1. Okay, so therefore this a of omega will be equal to 2 minus root 3, which was there already, and this thing here will have a DTFT as 2 minus root 3 to the power n minus 1 into u of n minus 1. So this is 2 minus root 3 to the power n minus 1 into u of n minus 1. So this I can simplify as 2 minus root 3.
Madam, this is A of n.
Sorry, a of n into u of n minus 1. Okay. So basically what we wanted to find out was this h of n will be equal to 1 by root 3 into a of n minus b of n. So we have found out this a of n here. Now what is remaining is to find out this b of n. So for this b of n, we need to look at this quantity here. Okay. So now let us consider this quantity. Or let us consider minus b of n, b of omega. So consider now minus b of omega. So this will have DTFT as minus b of n. So minus b of omega is equal to e power minus j omega upon 2 minus root 3 minus e power minus j omega, which is equal to, I can write this as 1 upon, minus sign here, sorry, 1 upon 1 minus 2 minus root 3 into e power j omega. Okay. Now to understand what is happening to this thing is, this is not in a standard form which we had looked at. We don't have a minus sign here. This is less than minus 1, but this is not, this doesn't have a minus sign. So this is not in a standard form which we were till now looking at. So now in order to understand that, consider this quantity. Let's say this is x1 of n, and again I have magnitude of a as less than 1. Okay, so now the DTFT of this quantity will be x1 of omega is equal to summation n running from minus infinity to infinity a to the power minus n into u of minus n into e power minus j omega n. Now u of minus n means this thing will be non-zero for n less than or equal to 0. So now we'll have summation n running from minus infinity to 0 a power minus n into e power minus j omega n. Now what we will do is replace n as minus m. So if n is ranging from minus infinity to 0, this m will range from 0 to infinity. So we have summation m running from 0 to infinity a power m into e power j omega m, which is equal to summation m running from 0 to infinity a into e power j omega to the power m, which is equal to 1 upon 1 minus a into e power j omega. So why is it so? This is again an infinite geometric progression standard trick with common ratio as a into e power j omega, and magnitude of this quantity is equal to magnitude of a, which we have set as less than 1. So if I have xn of this form with magnitude of a less than 1, then my DTFT will be of this form 1 upon a into e power j omega. This is exactly the same thing that we are having here. So what do we have is minus b of omega is equal to 1 upon 1 minus 2 minus root 3 into e power j omega, and if we compare it with this form, if we compare this and this, then here a is equal to 2 minus root 3 and magnitude of a is less than 1. So therefore minus b of n will be equal to this thing, minus a to the power minus n into u of minus n. So this thing here will be equal to 2 minus root 3 to the power minus n into u of minus n. So now what all things do we have? We have a of n and we have b of n. So let us substitute it in this equation that we need to find out. So what we need to find out is hn is equal to 1 by root 3 multiplied by a of n minus b of n. So this a of n we had found out as 2 minus root 3 to the power n into u of n minus 1, and this minus b of n is 2 minus root 3 to the power minus 1, minus n into u of minus n. So this is our h of n. But this is not our final answer. What does the question ask? Question asks us 3 values. So the question demands us h of minus 1, h of 0 and h of 1. So the only thing that we need to do is we need to just substitute n equal to minus 1, 1 and 0 in the final expression that we have found out here. So let us do that. So let us first find out h of minus 1. So this thing will be 1 by root 3, then 2 minus root 3 to the power minus 1 into u of minus 2 plus 2 minus root 3 to the power 1 into u of 1. So this thing is, this u of minus 2 is equal to 0, only this term survives. So this thing here is 2 by root 3 minus 1. Okay, so now let us find out h of 0. So this thing here is 1 by root 3 . Then we have 2 minus root 3 to the power n, which is 0. Then u of n minus 1, which is u of minus 1, plus 2 minus root 3. Sorry to something. Okay. To the power 0 into u of 0. So this thing comes out to be 1 by root 3. So this thing here is equal to 1, this thing here is also equal to 1, and this thing here is equal to 0. and h of 1 will be equal to 1 by root 3 into 2 minus root 3 to the power 1 into u of 0 plus 2 minus root 3 to the power minus 1 into u of minus 1. Okay, so this is what we are having. So this quantity will be equal to 0, this is equal to 1. So what we are left with is 2 by root 3 minus 1. So h of 1 is equal to 2 by root 3 minus 1. Any questions? Any questions in this particular part?
Madam, it is too lengthy, no? This procedure.
Yeah, it's too lengthy, and
Can we
there is
go
no
with
simpler way. Okay, shall I go through it
trigonometric?
once more?
No, no need, madam. Trigonometric relations can we make use of?
We can make use, but in trigonometric relations also the main issue is it's not simply integration of 1 upon 2 minus cos of omega,
Oh,
right? So yeah, I understand that what you can do is you can write it as 1 plus 1 minus cos of omega, then do 1
yeah,
minus cos of,
cos
yeah,
omega, we can write it as cos
yeah,
square omega by 2 minus sin square omega by 2. But like
yes.
that, we can bring it to secant, and from there we can get to tan.
But one more thing,
Yes,
that integration, what you need to do is h of n is equal to 1 over 2 pi integral minus pi to pi h of omega into e power j omega n d omega. So I
d
don't
omega.
know how this will behave. Maybe this
Yeah, that
also you will have to write as cos of omega n plus j times sin omega n. Another issue
also
with
very
that is
complication.
this
Yeah.
omega n is there. It's not simple omega, it's omega n.
Oh,
So in
okay.
that situation, you will have to substitute omega as 1 and minus 1 and then simplify. You may try to do that. You may get a closed form. You can try it once.
Yeah,
I
yeah.
think you
Oh,
may get.
okay.
Yeah. Yeah, for plus minus 1 you can get, but for generalized n, I don't think you will get a closed form.
Oh,
It will be too complicated.
okay.
Yeah. Any other questions? So basically, if you observe, if you knew this relation, na, this thing here, then the problem is very simple. You just need to bring it to some standard form. And this kind of approach will use left and right in Z transform, because finding
Okay.
inverse Z transform is too complicated using standard equation. You will see that in coming weeks.
Okay.
Yeah. Okay, any other questions? Okay. If there are no further questions, then let me go on to the next question. Yeah. So the next question says that we need to find the DTFT of this signal here, x of n equal to delta n minus 2 and plus delta n plus 2. Okay, so what we need to do is we need to find the DTFT of this given signal. So for that, what we'll do is we'll find a generalized thing. So for this question, let us consider this signal. Okay, and let us find out the DTFT of this signal. So if we have the DTFT of this signal, it is very easy to find out these two. It is simply setting n equal to 2 here, n not equal to 2 here, and n not equal to minus 2 here. So let us try to find out this. So this thing will have a DTFT as summation n running from minus infinity to infinity delta n minus n naught into e power minus j omega n. So now what happens is this, we are multiplying this quantity with this impulse here. So this is exactly equal to summation n running from minus infinity to infinity delta n minus n naught into e power minus j omega n naught, where this thing is constant and this thing here is equal to 1. So this thing is simply equal to e power minus j omega n naught. So what we have found out is delta n minus n naught has a DTFT as e power minus j omega n naught. Okay. Now what is the x of n we are given? So this x of n is equal to delta n minus 2 plus delta n plus 2. So for this case, if we compare this quantity with this quantity here, then we can write that, we can say that here n naught is equal to 2. And similarly, if we observe this quantity here and compare it with this quantity here, then again we have n naught equal to minus 2. Okay, so in that situation, x of omega will be equal to the Fourier transform DTFT of this quantity, which will be equal to e power minus j omega n naught, which is 2, plus DTFT of this quantity, which is equal to e power minus j omega n naught, which is minus 2. So now,
Madam, one doubt. Madam.
yes.
Yeah. Actually, we have to write this as x of e power j omega, no, madam?
Sorry, where?
X of, it is DTFT is x of e power j omega, no? It is a function of e power j omega, no? You are using x of omega.
Where?
Here, madam, x of omega is equal to u dot. Actually, it is x of e power j omega. It is a function of e power j omega, no, madam?
Sir, generally different books use different notations, and x of omega is equal to x of e power j omega.
X
So
of
this
omega
particular
used,
course is using this notation, so I'm following that.
you are using both, madam. In the assignments also, somewhere we are seeing x of e power j omega. In some places, it is x of omega. We are getting confusion in the assignments
Um,
also.
for these
Yeah.
confusions, please write to the portal. Actually, assignments and all those things are not in my hands, sir.
Okay.
Yeah,
Okay.
please write to them, like, or you
Okay.
have a session on 20th, right, with the course
Yes,
instructor.
sir.
So
Okay.
just mention these points directly to the instructor. It would be better. He will also handle it in a better
Okay.
way then.
Okay.
Yeah, these kind of like technical and this admin kind of issues, just tell him on that day. He'll take care of it.
Okay.
Yeah, thanks. Yeah, in the lectures, in the video lectures, this particular notation is being used, so I'm continuing with this notation. Okay, so this thing here is e power j to omega plus e power minus j to omega. I can multiply and divide by 2. So this quantity here is simply cos of 2 omega. So therefore, x of omega is equal to 2 times cos of 2 omega. Any other questions? This is the final answer that we wanted to find out. Any other questions regarding this? Okay. Another thing that I will like to mention here, try to remember the standard results that we show. For example, this thing, then the DTFT of a power minus n into u of minus n, 8 power minus n into u of n, and the time shift property, and similar other general results. This will help you sometimes to solve these kind of questions in a faster way. Also, if some of you are giving any competitive exams, then yeah, many times properties help a lot in competitive exams, and even these generalized results, general results. If there are no questions, then let me move on to another question, the next question. So it says that a filter has impulse response as h of n into e power h of n equal to 3 to the power minus n into un if the input is xn equal to 2 to the power minus n un. We need to find the energy spectral density of the output. Okay, so these are the two things. So what we are given is we have a filter. So filter is an LTI system. Then so this LTI system has impulse response h of n as 3 power minus n into u of n, and input to this system is xn, which is equal to 2 to the power minus n into u of n, and y of n is equal to xn convolved with h of n. And let's say this thing have DTFT as x1 of omega, this thing let it have DTFT as x2 of omega, and this thing let it have DTFT as y of omega. So the energy spectral density of output, is magnitude of y of omega square. Okay, now if you remember this thing, okay, before that, so this thing is equal to y of omega is simply equal to x1 of omega into x2 of omega, x of omega into h of omega square, which is equal to magnitude of x of omega square into magnitude of h of omega square. And this is through,
Madam,
yes sir.
madam, in the top also please correct the same sentence. No, that h of n, beside h of n you wrote x1 of omega. Make it as h of omega. Yeah.
Sorry.
Yeah.
Sorry. Yeah. Sorry for this confusion. Yeah. Okay, so this h of n is equal to 3 power minus n u of n. Let it have DTFT as h of omega. X of n is equal to 2 to the power minus n u of n. Let it have DTFT as x of omega. Y of n is convolution of x of n with h of n, and let it have its DTFT as y of omega. Now using the convolution property, this y of omega is simply multiplication of h of omega and x of omega. And the energy spectral density is given as magnitude of y of omega square. So I can replace this y of omega as x of omega multiplied with h of omega like this. So now what we have is h of n as 3 power minus n into un, and we had found out this earlier. So h of omega, or rather this is of the form of a power n u of minus n. So this is of the form, this has DTFT as 1 upon 1 minus 1 by 3 into e power minus j omega, and x of n is equal to 2 to the power minus n into u of n, and this quantity has DTFT as x of omega, which is equal to 1 upon 1 minus 1 by 2 into e power minus j omega. So therefore magnitude of y of omega square is equal to magnitude of 1 upon 1 minus 1 by 3 into e power minus j omega square multiplied by 1 upon 1 minus 1 by 2 into e power minus j omega square. Okay, so now again what we can do is we'll try to simplify this. So this I can write as 1 upon magnitude of 1 minus 1 by 3 into e power minus j omega square into 1 minus 1 by 2 into e power minus j omega square. Now again these two things are of the form of magnitude of 1 minus a into e power minus j omega square. I can write this as 1 minus a times cos of omega minus j times sine of omega square. Now I can combine the real terms, so I have 1 minus a cos omega plus j a sine of omega square. So this thing is minus a cos of omega square plus a square sine square of omega. So this thing here is 1 minus 2a cos omega plus a square cos square omega plus a square sine square omega. So if I combine these two terms, this will simply be equal to a square. So I have 1 plus a square minus 2a cos of omega. So this thing is equal to, so this is 1 minus 1 a into e power minus j omega square. So this is what we are having. And the energy spectral density that we had found out was of this form. Magnitude of y of omega square is equal to 1 upon 1 minus 1 by 3 into e power minus j omega square multiplied by 1 minus 1 by 2 into e power minus j omega square. Right. So now for this particular thing, the value of a is 1 by 3. So we have 1 upon 1 minus, sorry, 1. For this particular case, it will be 1 plus a square will be 1 by 9 minus 2a cos omega. So a is 1 by 3 into 1 plus a square here is 1 by 2 square. So 1 by 4 minus cos of omega. So this is my energy spectral density. Any questions?
No problem.
Okay.
No question.
Okay. Okay, if there are no questions, then let's go ahead with the third question, ninth question. Okay, so what it says is, let S equal to this thing here be an orthonormal basis of in R3, and let there be a vector u in R3. So we need to represent this u, or rather we need to find coordinate vector of this u, of this vector u. So what do we mean by coordinate vector? So this u bar, so for simplicity, this S is a set of bases. So what we will do is we'll represent this vector as u1 cap, this as u2 cap, and this thing as u3 cap. So a vector u can be represented as A1 U1 cap plus A2 U2 cap plus A3 U3 cap, where these three things U1, U2 and U3 are the basis vectors, and this A1, A2 and A3 are the corresponding coordinates. So this vector A1, so this vector A1, A2 and A3, this thing is coordinate vector of U bar for this given basis. Okay, so how do we find this A1? This A1 is simply the projection of this vector U bar, over the basis U1 cap. So projection is found out using inner product or dot product. So this thing is simply U bar, inner product of U bar and U1 cap. Similarly, this A2 is projection of U bar over U2 cap, and A3 is simply projection of U bar on U3 hat. Okay, so let us find out A1. So this is projection of U bar on U1 hat. So this is equal to, what is my U bar? So this U bar is minus 3 to 5, and this U1 cap is 2 by 7, 6 by 7 and 3 by 7. So this thing here is minus 3 into 2 by 7 plus 2 into 6 by 7 plus 5 into 3 by 7. So this thing here is minus 6 plus 12 plus 15 by 7, which comes out to be 21 by 7, which is equal to 3. Okay, so this is my A1. Similarly, I can find out A2, which is U bar, inner product of U bar with U2 cap. So this thing is inner product of the vector, that is minus 3 to 5 with 3 by 7, 2 by 7 and minus 6 by 7. So this thing is equal to minus 3 into 3 by 7 plus 2 into 2 by 7 plus 5 into minus 6 by 7. So this is equal to minus 9 plus 4 minus 30 by 7, which is equal to minus 35 by 7, which is equal to minus 5. Okay, and in similar way, I can find out A3, which is equal to inner product of U bar with U3 cap, which is equal to inner product of minus 3 to 5 with 6 by 7 minus 3 by 7 and 2 by 7. So this is equal to minus 3 into 6 by 7 plus 2 into minus 3 by 7 plus 5 into 2 by 7. So this is equal to minus 18 minus 6 plus 10 upon 7, which is equal to minus 14 by 7, which is equal to minus 2. So what do we have? We have A1 as 3, A2 as minus 5 and A3 as minus 2. So we can represent this vector U bar as 3 times U1 cap minus 5 times U2 cap minus 2 times U3 cap, and therefore coordinate vector is equal to 3, minus 5 and minus 2. Is it okay? Any questions? Any questions in this particular part? Okay, if there are no questions, then let me go ahead with the last question that I had planned to cover today. So it says that let xn be a complex valued discrete time signal, okay, whose DTFT is denoted by x of omega. And since it is a complex valued signal, I can represent it as real part plus j times imaginary part. Okay. And this xr of n and xc of n are both real valued signals. So what the question is, we need to find the DTFTs of xr of n and xc of n. So what is given to us? So it says that x of n is complex signal, or rather complex valued signal, and this xn I can write as real part of it plus j times imaginary part of it, and xr of n and xc of n both are real. Okay, so another thing that is given to us is x of omega is equal to, this x of n has DTFT as x of omega, and what we need to find out is what is the DTFT of xr of n. Let's say it is given by xr of omega as some function of x of omega, or rather let me write it afterwards. So what is this? And xc of n, let it be xc of omega. We need to find out this, and both of these we need to find out in terms of x of omega. Okay, so we need to find it out. So let us try to do that. So the only thing that we know here is the relation between x of n and xr of n plus j times xc of n. Now what we will do is take complex conjugate, so we have x of n conjugate is equal to xr of n minus j times xc of n. So if I take a plus jb conjugate, this will be equal to a minus jb, where a and b are real and imaginary part of that complex number respectively. Right, so this we have. Now if I want to find out xr of n using these two equations, what I can do is I can add up these two equations. So if I add these two equations, what will happen is these two terms will get cancelled, and I'll have 2 times xr of n as x of n plus x bar of n. So what we will do is, let's say this is 1 and this is 2. So we will do 1 plus 2. So that will lead to x of n plus x of n conjugate which is equal to 2 times xr of n. So therefore xr of n is equal to x of n plus x of n conjugate whole divided by 2. Okay, now let us find out xr of omega. So that will be equal to DTFT of x of n, which is x of omega, plus DTFT of x conjugate of n. So if x of n has DTFT as x of omega, then x conjugate of n will have DTFT as x of minus omega whole conjugate divided by 2. Okay, so this is the DTFT of xr of n in terms of x of omega. Okay, so this we have found out for xr of n. Now we need to find out the same thing for xc of n. So how can we eliminate this xr of omega? So we can do 1 minus 2. So in that situation, these two things will get cancelled. So now what we will do? So we will do equation 1 minus 2. So we have x of n minus x of n conjugate, which is equal to, so here these two things will get cancelled and this will get added with this term here. So we will have 2j times xc of n. So therefore this xc of n is equal to x of n minus x of n conjugate divided by 2j. Therefore xc of omega is equal to Fourier transform of x of n, which is x of omega, minus Fourier transform of x conjugate of n, which is x of minus omega conjugate divided by 2j. So this was the DTFT of xr of omega, and this thing here is DTFT of xc of n. So this is what we wanted to find out. Any questions? This was all I wanted to cover today. If you have any questions in any part of today's tutorial, please feel free to ask. I think assignment 1 and 2 detailed solutions are available, and I think there are few ambiguities in that. So hopefully those things will be sorted out in the session on 20th, I hope. Any other questions regarding today's tutorial and other things? Sorry?
No questions, madam.
Okay, thanks. If you have questions, please ask. Otherwise, you are free to leave the meeting. Thank you for attending today's session. Hope to see you all in the next session as well.